have you ever wondered how OpenSearch and Elasticsearch stack up to each other? My name is Evan Downing, and I'm a security researcher working for Trail of Bits, and our goal is to bring repeatable benchmarking to the masses. Last year, AWS approached us with a goal to help them fairly benchmark OpenSearch and Elasticsearch. To give some brief background, in 2021, AWS forked Elasticsearch due to licensing issues, and they named it OpenSearch. So in terms of code organization, both engines generally share the same code base, but since then there have been significant changes to both engines in terms of their implementations. In order to benchmark OpenSearch and Elasticsearch, we ran OpenSearch benchmarks. They are a suite of timed queries which helps measures how quickly each engine searches through large amounts of data. And originally it was developed as Rally under Elasticsearch, but then was forked to become OpenSearch Benchmark after OpenSearch was forked from Elasticsearch in 2021. But before I show you how we did this, let's get to the results first. So in March of this year, we published a blog post and a report, and this is the summary of that report. Overall, it was a mixed bag. When OpenSearch was faster, it was much faster than Elasticsearch. But Elasticsearch seemed to be faster at more of the tasks. But really, this slide isn't the main point of this presentation. These numbers will only change over time, and it's a drop in the bucket in terms of results overall. So the point of this presentation is we were able to get these results easily by building a framework for automated repeatable benchmarking. So none of the results that I showed you was obtained manually. We open sourced our framework, which is shown here. I'll show a link to this in the last slide at the end of the presentation. When we started out, we noticed three primary challenges. First, OpenSearch and Elasticsearch run nightly benchmarks, but they use two separate setups. So it's not easily comparable. It's not apples to apples. Second, neither search engine is regularly compared to each other continuously, other than obviously in blog posts and reports. And finally, both implementations are changing rapidly, with both search engines having tens to hundreds of commits every week on GitHub. So our solution to this was to build a cloud-based testing framework. We use GitHub Actions to deploy brand new AWS cloud instances for each test. And we ran multiple workloads, multiple runs daily. So our overall goal is to be a neutral bridge between the two search engines, and for that matter, other search engines. So to amend, to enhance snapshots of results in blog posts and reports, including our own, we want the public debate to be over the configurations of each of these search engines and the workloads measured, and not necessarily the hardware or the resources allocated. We want the comparison data sets to be 100% transparent and open sourced, easily corresponding to each benchmark that was run, to have a bit of a more holistic conversation around search engines. So for our report, which again was published back in March, so these are a bit older results for these older engines. We will have new results at the end of the presentation. This is our general setup. This is our methodology. So at the time, we compared OpenSearch 2.17 and Elasticsearch 8.15. We used a variety of OpenSearch benchmark workloads, including Big 5, PMC, NYC Taxis, Vectorsearch, et cetera. We used the same configuration settings for both search engines. So whenever one search engine configuration had to change for one reason or another, we went to the other search engine and read documentation, consulted with engineers, and made sure that the configurations were as fair as possible, as consistent as possible. We deployed fresh AWS instances for 15 days. We used 90th percentile measurements for the service time, which is the time it takes from a query, when the user clicks to actually deploy the query to when the query results get back. We ran 5 tests per day, discarding the first as a warm-up for cache. And in the end, we had thousands to tens of thousands of sample measurements per operation per run, which at the end of this report, that means we had tens of thousands, if not hundreds of thousands of sample measurements. So we didn't want to just publish results. We also wanted to validate and verify that they were something that we could draw conclusions from. So we spent 9 weeks deploying and running both search engines on these benchmarks. And we wanted to measure 2 statistical validation measurements. One, which is the p-value, which basically tells you if you're able to see a difference, what was the probability that that was just a random chance that you saw that there was a difference. And the second is the statistical power, which measures the likelihood that you could even see a difference in your data set. And using these standard thresholds, we were able to verify over those 9 weeks period that we could draw these conclusions reliably from our data set. So I'm going to show you just how easy this is to run, hopefully. Let's see if it goes. All right. There it is. OK. So what you're seeing right now is a private fork of the public repository that we've open sourced. It's private because GitHub Actions has some security concerns with it if you try to publicly allow anyone to run here GitHub Actions. So here you can choose to run whatever workload on whatever branch you want of the repository, whatever workload, OpenSearch Benchmark workload, custom parameters, whichever search engine, and whichever versions of those search engines that you'd like to run. And afterwards, you just click Run Workflow. And after this is created, you'll see the workload pop up on GitHub Actions. And you can click there, and you can see which step it's on during the duration of these runs here. So after you click on it, you can see that it's starting to deploy the EC2 instances. And after the workloads are finished running, you'll see something like this. Here is a full list of all the benchmarks we ran. So you can see there's lots of different configurations for Big 5 that we ran. Again, each step of the process. So it's easy to identify where things go wrong or not. And afterwards, it pops out a spreadsheet that looks like this using our scripts. And I know this font's really tiny, but basically allows you to go through all the results easily and quickly compare what your results looked like and what conclusions you can draw from them or not. So why is this important? This is important because during our benchmarking, we noticed that there were some outliers in performances for both search engines, for OpenSearch and Elasticsearch, which we, at least to our knowledge, was previously unknown. And again, this is important because if you had just run these search engines for maybe a few days, you wouldn't necessarily see these type of results. These results we were only to see after running them for 2 weeks on end. And you'll see here I've highlighted 2 separate boxes here where you'll see these large jumps in performance here, which indicates something that's interesting. So we wanted to dig in to these results. We are currently actively diagnosing what these outliers are. Again, with the benefit of our framework with automated repeatable testing, it's easy to continuously keep running tests to reproduce these outliers. But as you can see here, we've tried controlling for lots of different things. And we are still, again, currently working to diagnose this. But automated benchmarking makes this easier to at least work to diagnose. So what are things happening now? So as I said, back in March, we reported the results on 2.17 and 8.15. These are the newer results from just a couple of months ago. So both OpenSearch and Elasticsearch released new major versions. And so far, everything's going great for both search engines. Both search engine results have improved over the prior major versions. OpenSearch has maintained its lead in data histogram and term aggregation performance. There's still some work to be done on text querying, but it's narrowing the gap. So you'll see in the latest major versions or minor versions of version 2 for OpenSearch, it's closing the gap from being almost 3 times slower than Elasticsearch to now 1.4 times slower than Elasticsearch. So there's been some great improvement over the past out of the past many months. The 2 current operations that are the slowest for text querying right now on OpenSearch is query string on message and query string on message filtered. But going forward, what's our what's our end goal? We are currently today expanding the framework to support more search engines to paint a more complete picture for how everyone else stacks up to each other. So mainly we're working to add support for Milvus and Vespa. We're looking to support other benchmark workloads, which have been used to measure vector search, like Big An. And our aim is to continue to be as transparent as we can and post regular benchmarking results as frequently as possible. So the bottom line is we built a tool to help users automatically benchmark OpenSearch and Elasticsearch to figure out which one fits their needs the best. Using automation for repeatability and reproducibility, we help make comparing these search engines a little bit easier. And this is the work that Trilobits really enjoys doing. We like to build tools that maybe you don't have the engineering bandwidth to allocate at the moment. And we are here to help the open source community. So you'll see here, there are links to the open source framework that we've released, the blog post, and in that blog post, there's a link to the full report where you can find lots more details of the results that I just posted, and our contact information. So thank you for your attention. So we have a little bit of time, so if anyone has any questions, we can take them now. Yes, yeah, so sorry, yeah, color-coded here. The dark green means that OpenSearch is at least twice as fast as Elasticsearch. The dark red means OpenSearch is at least twice as slow as Elasticsearch. The light red means it's between 0 and 2, or 1 and 2, I should say, slower than Elasticsearch.
So go from 6.28 to 12.21, those are response seconds?
Yes, these are in milliseconds, these numbers are, yeah, exactly. Oh, from the front end? No. So to my knowledge, OpenSearch Benchmark is just going to, is just a suite of workloads. So it's just going to automatically do those queries. It's not going through the front end. It's just using APIs to query the backends. And again, the reason why this was feasible to do in the beginning is because, as I said before, the code bases are so similar. The APIs are pretty similar, so it's easy for everything to be consistent. We are now expanding to more search engines which don't necessarily have those same APIs, so it's a bit of a challenge right now. But yeah, so.
Sorry, and also for measuring each query, there's some query is more expensive than others.
Yes.
Which kind of query do you use to benchmark?
Yeah. Great question, yeah. So this is just a snapshot of, this is specifically just on the Big 5 workload. And the Big 5 workload was originally, again, designed by Elasticsearch to kind of be the more holistic workload of like, there's different types of queries. You'll see here there's like categories. Each of those categories has like between 10 and like more operations. And each of those operations is a specific type of query for that operation. So this is just one snapshot of that. Each workload will have a certain type of query that it's testing against. So for example, if you have dates and you want to say, okay, is this date between, or show me all the records between this date and this date, that's a type of date, query for date histogram when you're trying to bucket these things. So it just sort of depends. But there's a variety that we benchmarked against, so try to be as holistic as possible. Custom workloads? So right now the framework it only works on OpenSearch benchmarks currently. We are currently discussing adding, like how to add support from, because obviously there's lots of benchmarking frameworks out there that we could run. Right now, if your workload runs on OpenSearch Benchmark, the repository, then the answer is yes, it will run here. If it's not, it is a discussion for current work. But yeah, great question. That's a great question. So this framework is just to measure, just to compare the search engines. So the OpenSearch Benchmark suite has lots of different numbers they do compare. When we were collaborating and working with AWS, they really wanted to focus on service time, but they measured the OpenSearch Benchmark measures lots of different things like latency and other things like this. In our reports, we did mention these things, but of course, OpenSearch Benchmark collects all of these numbers, so feasibly you could, but it's just taking in information that is produced by OpenSearch Benchmark.
When we try to benchmark, are we able to apply to different setup for different deployments? For example, different size of the cluster?
Yeah, great question. The answer is yes. Actually, for the vector search comparison, we did deploy with like a three node cluster to do these different types of comparisons. So yeah, the short answer is yes. Again, we're currently going through a bit of a refactoring period. Some of our scripts are a little duplicitous and there's some cleanup to do. But overall, like it's very easy to reconfigure all of these things to launch whatever type of instance you'd like to on the EC2, and from the EC2 side and everything else. So it's highly configurable is my short answer. Yeah. Yeah. Yes. How do I explain the difference? Oh, like what happened between there? That's a great question. I think it's a better question probably for the OpenSearch engineers and Elasticsearch engineers. There have been a lot of changes, including lots of updates to, I guess the short answer is there's just been a lot of implementation changes, and we haven't yet dug into like implementation-wise, what were the reasons for all of these changes. We ended up spending a lot more time on just building the framework itself. But it's a great point, and it's a definite goal for us to help diagnose reasons for why one is either improving or maybe there's some regressions sometimes in operation performances. Even for both search engines, if you look at the nightly runs, sometimes they kind of go up and down and up and down. But we haven't gotten to that stage yet. But that's a great that's a great moonshot, I guess. Okay. Yes. Mm-hmm. That's a great question. So we're still exploring right now. The short answer is what we would like to do is there's always a snapshot stage for these search engines where you'll snapshot the data set or the indexes. That we're planning on just using those own search engines for those snapshots. And then what we plan to do is we looked behind the scenes on Milvus and Vespa here. And they do have APIs that we could retrofit into OpenSearch benchmarks, so we can find equivalent APIs is what I'm trying to say. And that's the current status, but again, we're kind of still working through that. But that's the ultimate goal, because the biggest problem with adding support for other benchmarking frameworks into this is consistency. So we're trying to compare apples to apples as much as possible, and OpenSearch Benchmark is going to time things potentially in different ways than maybe even Rally does nowadays, or other, Milvus has its own benchmarking framework, and so does Vespa. And we wouldn't necessarily want to compare one to the other, so we are trying to keep everything as close to everything runs on OpenSearch Benchmark as possible to make things as neutral as possible. Okay. Any other questions? Yes. Yeah, that's a great question. So we run one instance per benchmark. So are you asking like how many resources would it take to reproduce our report? Yeah. So if I'm recalling back of the envelope math, it takes about, to what we did, it was about $500 a day to deploy all of the resources that we did, because we did a lot of benchmarks. We had lots of different configurations for Vectorsearch and et cetera, et cetera. We also compared like I think we compared like 3 or 4 versions of OpenSearch and Elasticsearch to each other, so we can see a trend line, a trajectory. So it was, to produce this report, the 2-week report, it was several thousands of dollars, if not a little bit more. But again, you can configure these things however you want to. You don't have to spend that much. You can, like I showed in what we did is we had these nightly benchmarks that took that kind of resource, but you can manually do all this yourself and say, I only want to do a very small test on using this smaller EC2 instance, and it will just go and fetch that. So you don't have to do the extensiveness that we did, but in order to reproduce it, yes, you would have to, all of it's scriptable, so you can just run our scripts and it'll just hook it up to your AWS account and hope that you have enough in there. But yeah. Okay, any other questions? Okay, thank you.